Hello, STEAM Chem. This is our first video lecture that you're going to get. We talked about flip the classroom in our class. And so now what I'm going to do is give you a video on some of the stuff, review that you should already know, that we'll go over, so that you're prepared for the lab that you have coming up and the information that you need to know. So one of the things I want to go over is some lab equipment that you should already know. So if you don't remember, I have to figure out where the camera is, so please be patient. So this is your graduated cylinder, okay? Has a nice little bottom. If you remember what this top is for, I'm going to go ahead and switch the camera so you can see. So on my desk, there's the graduated cylinder. And remember what that top's for is if you knock it over, it helps keep the glass safe so it doesn't break. So make sure it has this piece. You want to make sure that when it falls, there's that protection. So please keep that piece there, always up at the top. It's not for measuring. It's not meant to be down here. It's meant to be all the way up at the top to protect it, so that way you can push it over and it protects it. So be aware of that. The other thing you need to remember for equipment is this, which is a beaker. Remember? So a beaker. You have your thermometer, and you will have your triple beam balance that you have here. Make sure it's zeroed out, and when you do, so mine is zeroed, make sure that it is balanced out. Obviously mine is not balanced, so I have to work with the end here as soon as it's tough, and I have to twist the end whichever way it needs to for it to move. It's not moving, so we'll go this way. Maybe my knobs aren't on the notches. So make sure this arrow lines up with the zero right here. I must have a bad triple beam balance. So it should look like this. Make sure it's zeroed out. If not, you have to mess with this end to move it up or down. And I will get a new triple beam balance for what we're going to do today. Or at least you'll be able to see what we're going to do today with this triple beam balance. So we're going to put all that aside. We're going to go through the proper measurements of all of these equipments, including their accuracy. So accuracy is very important, especially in chemistry. We do not want to have that slight change. I should be able to repeat your experiment in the accuracy that the equipment is. So with graduated cylinders, it can change. This one's 100 milliliters. So if you look off to the side, there's 100 milliliters there. Usually you can see that in all equipment. The beaker, it's off to the side right here. It says 250 milliliters. So we usually don't measure with the beaker. Don't forget, it's usually graduated cylinder. So when we look at the little lines, so when you look at the lines, I'm going to turn this so you can see it. Hopefully you can see it a little better. I'll get it right in front of my face so you can see the lines. All right, so you have 70 here, and you'll see that it goes up by 71, 2, 3, 4, 5. There's 75, and then up to 80. You can see in between those lines, which means if it's in between those lines, it'd be 75.1 or 75.2 or 75.3. That is the accuracy of this graduated cylinder. This is one place past the decimal. Now, not all graduated cylinders are going to be one place past the decimal. Some will be two places past. If you are unsure which one it is, please ask me in class and we will make sure that you have the right accuracy. It is important to have the right accuracy with the equipment. Now, for proper measuring, what you need to do is this needs to be on a flat surface. You cannot hold it up like this and say, oh, this is this. So once you pour in your water, so you're pouring your water, let's hope I don't get it on my computer. So I've poured it in. I'm not going to hold the graduated cylinder up here and try to guess where it is, because you're going to tip it back and forth, and so it doesn't give you an accurate measurement. So what you need to do is you need to stick it on a flat surface. So it's on my lab bench. And I'm going to turn this so you can see that. So it is on my lab bench. It's on a flat surface. And what I'm going to do is I'm going to get down at eye level, which means I have to crouch down, which I don't know if you're going to be able to see me, so I have to get down to eye level, which is right here, to be able to read it. No, you can't be standing above it and try to look down because you're not going to get an accurate measurement. You have to get at eye level with it. Some of you tall people, that means you're going to have to squat to get at eye level. So if I'm reading this, we're going to read at the bottom of the meniscus. Remember, the meniscus is the bottom of the curve. Because of surface tension, it curves on the side of the glass. So you want to read the bottom of that curve. And sometimes it's tough. Again, some of the things I like to do, because I can't see behind it, is I put a piece of paper right behind it so that I can read it. That is a good way of trying to see these measurements. So I'm going to put my paper behind. I'm going to see that is 40. It's not quite at the 1, so it's not 41. So it's 40, and I'm going to read in between those lines because that's where it is. It looks like it's 40.9. And not only that, you have to put 40.9 milliliters. So when I write this out for my measurement, I'm going to write it just like this. 40.9 milliliters. And that's how you do milliliters. Okay? So that's your quick review on graduated cylinders. Okay? For temperature, what you are going to do is you're going to put, here's my beaker full of liquid so that you can all see. I'm going to put my thermometer in the liquid where it doesn't touch the sides nor the bottom. I do not want to record it like this because remember, it's taking the temperature of the glass, not of the water. So I'm going to do this, and I'm going to hold it right here. And I'm going to wait for 1 minute. Remember, it's 1 minute. I'm going to wait for 1 minute. Leave it in there. Once it's been in there for 1 minute, don't hold it up and take the temperature, because what you're going to do is now change the temperature, and you're going to take the temperature of the air around it. You want to take the temperature of the liquid. So you're going to hold it in there. Bring this one up to eye level and read it. Again, thermometers can be different. This one happens to go just like that graduated cylinder, so it's going to be one place past the decimal. In this case, it looks like it is 24.5. That point whatever is going to be a guess. Where do you guess it in between the numbers? Okay. For the triple beam balance, now that I've gone through the equipment, what I'm going to do is my safety. So if you have long hair, pull it back. I have short hair, so it's not going to get into anything. I'm not going to have to worry about that. I have glasses, but that doesn't mean that my eyes are safe. So I'm going to go ahead and get my trusty dandy safety goggles on, just like this. And that's to keep me safe during an experiment. Again, long pants and closed-toed shoes. I have closed-toed shoes on. See? My awesome sneakers. So that's what we do to prepare for an experiment. You will have an experiment this week, so you need to make sure you're safe. Now, I want to continue with how to do density. And we've talked about density. We've gone over accuracy. Now we're going to talk about density. And if you remember, density, I showed you two different ways. Density, D, is mass over volume, written just like this. Okay? Now I showed you another way. If you remembered from last year, I showed you another way. It can look like this for my girls. Remember, I showed you this is one way of remembering it. It's the D with the broken heart. So that was another way that you remembered it. The half of the heart was the M, and the bottom half of the heart was the V. There was a third way that I showed you, and most of you like this, and this is the way that you're going to have to remember, which is the triangle way. Now, the triangle was DMV, and it looked like this. Now, remember that this line right here was your division. So mass divided by volume, and this line right here was your multiplication. Now I'll work through this for you to understand this again, okay? so that you can remember all of this. So if we wanted to find density, we cover, I'm on the wrong side, we cover up the D, and it's mass divided by volume, mass divided by volume. Now, if we wanted to manipulate this equation, we wanted to find volume, so I'm going to cover up the volume over here, and it still ends up being, but it's mass divided by density. So we cover it up, and you get mass up here divided by density. Now, if we wanted to know mass, so I'm going to cover up the mass, and you'll see that it's density times volume. So density times volume. Okay, that was the way, so you guys didn't have to manipulate the equation. This was your like cheat sheet of trying to figure it out. So when we do regular objects, so a cube just like this, to find mass, we put it on the triple beam balance and we find the mass. Remember, masses go 2 places past the decimal all the time. All the time. And if you can't figure out that accuracy, let me show you in class and in the lab that we're going to be doing. To find volume, because it is a regular, there's regular and irregular, but this is a regular shape. What we're going to do is find the volume of this cube. And if you remember, the volume of a cube is length times width times height. So I'm going to take the measurement of my cube, get that length, get the width, and then get the height. So then when I have my length and width and height, I multiply them, and that gives me my volume. So there's 2 ways you can find volume. Of a regular shape, again, so the regular shape is length times width times height, just like this. So regular shape, volume, length times width times height. So I stuck all those in for the cube. Now remember, the meter stick or ruler goes 2 places past the decimal. We are never using inches. We are using centimeters at all times, either centimeters or millimeters. In science class, we do not use the English Standard Version. We use the metric version. So never, ever, ever give me inches. So anyway, back to what I was saying. So we have length times width times height. I found my volume of my cube to be 4.33 centimeters cubed. Don't forget that cubed, because it is length in centimeters, width in centimeters, height in centimeters. When you multiply them, it becomes centimeters cubed. Now I found, let's say my mass was, I don't know, 40.38 grams. Remember to put your units in. Now to find density, what we're going to do is take that mass divided by volume. So we're going to have 40.38 grams divided by the volume. So you should have something that looks like this. Density is mass divided by volume, the mass being 40.38 grams and the volume being 4.33 centimeters cubed. At this point, you can stick it in your calculator. So I'm just going to get my calculator, which you should have a scientific calculator for class. It looks like this. I'm going to stick it in. Most people have troubles using their calculator. I can help you with that as well. So I'm going to put in the 40.38 grams, and I'm going to divide by 4.33. Now I get a density, if you've done this right and you've done it with the video, which you should, I get a density of 9.33. Now you have to be careful not to give me all those. Now the unit, so 9.33. And the unit's going to be grams per centimeters cubed. So that's my answer. It should look like this. Now, don't forget you have significant figures to take into account. And we talked about this last year. But we'll go into more about that later. For now, that is the answer. We'll get into significant figures a little more later. So don't stress about it. Don't worry about it. Right now, just do that and just go 2 places past the decimal for my answers, okay? So then, well, Ms. Crandall, what do we do for irregular shapes? Well, that's a very good answer, because it's easy for a cube like this. But let's say we have an object like I have here. I have a magnet. I shouldn't get that too close to my computer. But I have a magnet here. It's an irregular shape. Not only that, it has a hole in it. So how am I supposed to do it? I can find the mass, but I can't find the density. You're right. You can't.